All right, so now we're moving on to the mighty line segment. All right, so this is what a line segment looks like. It's different than a line. Why? It has a definite beginning and a definite end. All right. This has a finite length. It can be measured. You can take a tape measure, a ruler, you can get some kind of measurement of it. All right. And then the notation is you're going to write AB with the segment hat on top. You don't need to put the dots, just a little dash. Or you could call it segment BA. Order again doesn't matter. Or you could even write segment AB. So it is part of a line. And this has an infinite set of points within it. I mean, if I wanted to, I could put a point right there, there, and then I could zoom in even more, and then put more points there. If Notability would let me, I could keep zooming in and putting more and more points. All right, so it has an infinite set of points. It has 2 endpoints though, and that's what you name it by, 2 endpoints. And AB is the same as BA. All right, I already said that. So that's a line segment. Now we have a ray. A ray has a beginning, but then it goes infinitely forever in one direction. So we'll call this A, B. Being real creative. Okay, notation is you're going to call it A, B, and the segment hat always goes to the right. All right, or the ray hat always goes to the right. It's never, don't write like A, B, like that. That's bad. All right, that's just the way it is. We're not going to do it this way. We're going to do it this way. That's good. All right, a ray, again, is part of a line. All right, a line goes infinitely forever in 2 directions. This goes infinitely forever in 1 direction. I think there's a band called One Direction that you youngsters like. So this would go, keep going, it'd go all the way through my iPad screen, all the way forever and ever and ever. It begins at A and goes infinitely through B. All right, it's an infinite set of points. You can make them smaller and smaller. That extends in 1 direction. Okay, so that's just your typical ray. Now we're going to do some different things. All right, we're going to draw an example of 2 rays, AB and CA, that might seem like the same ray, but are different. All right, so this is what it's going to look like right here. Actually, I changed my mind. I want to draw the picture like this. No, we'll keep it like that. All right. All right. Ray CA, in this case right here, is different than ray AB because I guess I could have put it down here. CA is different than ray. Actually, time out. Me confusing myself. It's different than AB because different starting points. They both don't start at C. Different starting points. Okay, and then down here for this one, this is another example of how they can be different, where in this case ray CA and ray CA and ray CB are different again. I should have S right there. They have the same starting point but extend in different directions. All right, and then the last thing about rays is we're going to talk about opposite rays. All right, now opposite rays, again, in geometry, things are well named. We're going to do this. We're going to draw a line, B, A, C. Now, ray AB right here, it starts at A and it goes infinitely through B. Notice how this ray hat always points to the right. Doesn't matter what the picture looks like, it always points to the right. That's just the way we do it. Then AC starts at A and infinitely goes through C. All right, these are called opposite rays. Why? Same starting point, but they extend in exact opposite directions. Remember, rays, segments, all this stuff we're doing right now is the building blocks. We're going to be able to talk about supplementary angles and complementary angles and then prove really cool stuff because of these terms right here. All right, and then in the last video, we'll talk about plane.